Hello, hello everyone. This is Basanta Mahato from Electronics and Communication Engineering Department, IIMT College, Greater Noida. Today, I'm speak about a topic which is very relevant in design perspective view in electronics and communication, which is embedded system. How to design an embedded system, and what are the parameters to decide the uh, embedded system as a good manner, which people like it. Like the selection of how the embedded system flexible or low cost or speed. So these things are related to the core part of the embedded system. What is the core part of the embedded system? We already know it, that is called microprocessor or the microcontroller. So why we study this topic? We will study this topic today. So learning how microprocessor, microcontroller work and how to use them is very essential for every engineer in many ways. Every engineer has to know where we fit this microcontroller and which type of controller to use. So implementation algorithm for a communication system, control system, or any real-time system, we usually write a program and load the target on processor of the controller. Means every system we have means all the system which are automated. So how they work with that? So we have to load the codes or the command to them. So that's the implementation and algorithm for a communication system to the microprocessor or the controller. Then this processor or the controller is used as a part of the system. So it is the main core part. So here we conclude selection of tasks decide the system. Here I mentioned what is called system. It is an embedded system if the task is specific. A specific task is embedded system, and the system decides the type of microcontroller and the processor. So task decide the type processor to be used. Means your task decide what type of processor is going to be used. So here I have given an example, the block diagram. So whatever the outside is going on, it is called physical phenomena. That physical phenomena sensed by the sensor, and the signal is then signal condition, means to actuate the signal through the actuators and then pass it to the acquisition hardware. Acquisition hardware, because all the signals or the phenomena which we are getting from the sensors are mostly real time in nature, means analog in nature, which is continuous. The amplitude or the values are varying. So we have to condition it, and then it pass it to the computer. Means computer takes the digital signal and processes according to the instruction. So and inside the computer, what is the processing task is the software only. So software decides this, what type of process we have to do it. So then according to the command or the algorithm, the process starts and the data to be analyzed. So this is the mechanism of any data acquisition system. Next, introduction is minimize the cost and the power. If the system is a part of a battery power device, or it's required to keep the device cost low as much as possible, we have to use a cheap microcontroller. And the question is how to make the device cheaper. So that means the selection of the microprocessor to be cheaper. So how we do it? So to do so, the program should be minimized as possible, and the designer should make use of every element of the used microprocessor or the microcontroller. That means here you see the cost and the power directly corresponds to the microprocessor selection or the microcontroller selection. So it is a very great proverb. And in Egypt, the development of the field of electrical engineering in Egypt is our responsibility, not anyone else. So that means whatever be the development is to decide by ourselves to design. So to face the challenges facing our country these days, we have to be at technical level to allow to create a new product and compete in the global market. So what is the conclusion of these two statements? Is to do so, we have to be equipped with required knowledge and experience to innovate and bring new ideas that gives us the advantage in the market. What is the agenda of today's agenda is what is embedded system. So I'm going to discuss what is embedded system and how do we implement them. Implement them means how to design it, and what is microcontroller basically, what are the types, and how we differentiate all this, and developing embedded system using MCUs, microprocessor units, and what are the design issues, and finally conclusion. So everybody knows it's the embedded system. So embedded system is a special purpose system that is used to perform one or few dedicated function of the task. Suppose we have a camera. So what is the task of a camera? To capture an image or to capture few random images. That is called the video. Another is called a TV. What is the role of a TV? To broadcast a function. What is the printer? To print of the paper. Like, and what are the audio video system? There is a DVD and camera to capture the images. These are the simply we can call any computer system embedded inside an electronic device an embedded system. Embedded system is basically a microcomputer, we can say. So embedded systems are made to perform few tasks only. After implementation, you can't use them for another purpose. Suppose we have a microwave oven. It do only the only warm the foods only, but not to perform the other task. Suppose a washing machine is there. The washing machine only clean the clothes, so that will not perform the other task. So what are the examples of embedded system? Digital and analog televisions are there, DVD, VCDs, cable boxes, and personal digital assistants. These are called PDAs. MP3, iPod, kitchen appliances are the refrigerators, microwave, oven, and the telephone, cell phones, and the cameras. All type of camera is there, and global positioning system, GPS, and many more. Whatever we are seeing today in the world, real world, electronic gadgets which are automated are made up of this embedded system. The part of embedded system. We have the AC at our home. The AC is also functional because automated AC is there. So how do you implement them? We do so by using microcontrollers, obviously. So how are we going to actuate the signal? Suppose if we are taking the example of what I say is the washing machine. So for what time it rotates its motor inside the motor, and how long it takes to take the water inside it, and how to pour the detergent inside that, whether liquid or powder form, for how much time it took. For automatic systems, so it is already defined, and who is going to control the task is the microcontroller or the processor based system, or simply by using the digital circuits. But the complexity, yeah, this is the comparison of digital circuit and the microprocessor based system. Digital circuits are fast, but only propagation delay is there. But inside the microprocessor, if we use the system, it is very slower, dependent, and flexible. Digital circuits are flexible. Functions that are performed cannot be changed easily. But since we are dealing with the microprocessor, so we can reprogram the systems like that. So example of digital communication is the communication system. We are performing some algorithm over it, but microprocessor based systems are the, let's say, personal computers, PDA, mobile phones. So inside the mobile phone, suppose we have 3 to 4 applications are there, but if we want to change that application, we can do that easily at the PLC. So suppose we are performing 10 input output at a time to control. So suppose we want more than 10 or 20. So by changing the algorithm or the program, we can again reconstruct the process or the task. But in the digital circuits, we have to again rearrange the complete circuit. So that is the limitation. So that's why you always move for the microprocessor based system. What is a microcontroller? Micro is a small, controller means it's controlled. So it is a full computer system on a chip. So all the processing tasks inside the microprocessor, if its resources are far more limited than of a desktop personal. Yes, obvious. If it is a IC form, so it must have some specific size. So that means not the size limits, its area as well as the memory size, storage size, all are limited. So that means the speed is also going to be limited. So designed for a standalone operation for a specific task. Yeah. What is the microcontroller? So what is the difference between microprocessor and the microcontroller? It is a simple basically. So microcontroller, you see the microprocessor based system. Here you see it in the microprocessor based system. So general purpose microprocessor in CPU, RAM, ROM, IO port, and the timer serial ports all are differently added. Different blocks, entities which are assembled together and construct a general purpose microprocessor. But in microcontroller, within a single platform, where we embed all the things and within a single IC. So it is the area specific. What is the microcontroller? Yes, microcontroller has a processor and many peripheral integrated on a same chip. So these are all peripherals within a single chip we have, like flash memory, RAM, ROM, serial communication ADs. These are the peripherals which are incorporated within a single IC. So what is the microcontroller? A computer, a timer module to allow the CPU, MCU to perform tasks for certain time period. So that is already defined by the MCU because they are what you called the oscillator which generates the oscillation, the clocks are already defined. So that's why the one module allows the MCU to perform tasks for certain period of time. A serial IO port is to allow data to flow between MCU to other peripherals, and ADC is allowed to accept analog input for processing. So these are the functional blocks of microcontroller. But a microprocessor cannot do all the functions of a computer system on its own and need another circuit to support. Microprocessor needs all the different support systems: RAM, ROM, DMA, microcontroller, timer, ADC, LCD. But here you see these are inbuilt inside the system, not required a different blocks to perform. So then if we compare this microprocessor and microcontroller, we can conclude it that microcontroller depend mainly on its peripheral like program memory, IO ports, timer, interrupt circuitry, etc. General purpose microcontroller depend mainly on the other devices, like, so these are the depends on the peripheral. If you are not connecting the peripheral, so that much function is not going to happen. But in the microcontroller used for a few dedicated functions determined by the specific designer. We have already told regarding since the system is limited, so their dedicated functions are also limited. So we can perform the limited task. But in the general purpose, so we can perform any type of system. So if we replace the memory of let's say of 5 GB or 10 GB, so according to this, the application changes. Suppose we want to perform the five number of tasks, we can perform it. Suppose we have a 10 number of tasks, whatever be the size of it, we can change it accordingly. So usually used as a part of a large system, which is a microcontroller, but it is a heart of our PC. In our PC, we are used the microprocessor because it is a general purpose. We can perform any kind of task anytime. What are the popular microcontrollers? Yes, STM microelectronics is there. So these are the very popular nowadays. And Atmega 328, it is a 16-bit microcontroller, which are very popular with the ARM with the Arduino boards. Arduino board use this Atmega 328, and a PIC controller is there. Another is Attorney, Then MSP 430, it is very popular G2 series because it is a MSP, mixed signal processing. Signal processing type of works we can perform here, and it's a low cost, low power module. And EPS module is ESP module is there, and ESP32 very popular nowadays because we are using the applications of IoT. So this ESP module provides the IoT functionality, microcontroller as well as the all supporting peripherals of that IoT. And ATmega 32U4. This and how we develop the embedded system. So here is the two parts. One is called the software, and there is the hardware development part. We are going to design that. So if we talk about the hardware development part, so we what are the hardware we have? In MC, we include for application, for a specific application, so that we can satisfy the required specification. The criteria for choosing a microcontroller is how many number of input output we are taking, and what are the serial communication to be performed, and what are the peripheral lights like the timer, ADC, and the PWM. How much memory is required, and the processing speed is required, and what are the how much power consumption is required. So these are the criteria to choose a microcontroller. So then only we can decide according to the microcontroller. And the software development, writing the required algorithm using assembly or high level language, using a compiler and the assembler and the linker, and the finally debugging the codes for checking the syntax of the command. So software developments, what are the steps? Through high level, which is the compiler, and compiler goes to the machine code, that is hex code, and hex code goes to the device programmer, and program then goes to the program memory, and accordingly the device process the task. And the low level language, that is machine level, goes to the assembler. Assembler then goes to the machine code, and then goes to the device programmer, and then program memory finally. So under software development, using the assembly involves learning the used microcontroller specific instruction, but result in the most compact and the faster code. In C programming language, which is a high level, makes our code portable, which means that you can use it another target microcontroller without learning its instruction set. Because suppose if we are using this assembler for the low level language, we need to know the specific instruction set of that particular microcontroller. But if you use the high level languages, no need to do it. So that was already done through this compiler and the machine level. Machine code means the compiler itself does it. So that means C language advanced it, the selection process for another target microcontroller without learning its instruction. This easier the process software development, short time to market with acceptable quality. That's why high level languages C is so much popular nowadays. C versus assembly. Assembly programs are optimized more than C program, but to develop more complicated. Assembly has the specific. Using the C is more practicable and also efficient. So that's why it's popular. What is the role of linker? It's links. Link the function to link code from save different files together into a single file program. At the same time, it takes care of chip's memory allocated by using each instruction to a microcontroller memory address in such a way that different modules to do the overlaps. Debugger, yes, debugger we check the like checking the every instruction one by one line. So common features is the capability to examine and modify the microcontroller on chip register. Second one is stop and pausing program executing at defined program location by setting breakpoints. So it automatically do it. Single stepping, execute one instruction at a time through the codes and looking at the history of executed codes done through the compiler. Software development, nowadays we are using the very integrated modules where we use the integrated development boards that puts all the previous discussion software component under one common unified user interface. Like we are right now, we are using the Arduino boards. So that is an integrated development environment. Suppose we are currently we are using the RFID board. So that boards are the example of integrated development environment. So here you there you within a single platform, you simply flash the code, it automatically runs over it and perform the task. So what are the design challenges in it? What are the design challenges? The system must be fast. Whatever with the current design, current speed, means the faster module must be there, and size. If we limit the size, that means we are talking about the space, area, and how much supporting IO is there. What are the number of input output modules and supporting protocols? It is very important, because supporting protocol decides the microcontroller. In normal microcontrollers, only 2 or 3 protocol integrated, but in support. And shape and the size. Shape and the size means looks. And internal and external memory. So if we conclude it, so for a specific task decide all the design parameters. That means suppose we are going to design a system. Let's say in our case currently, suppose we are going to design an washing machine. This is our specific task. So decide all the design parameter. Design parameter means how much speed of the motor could be, how much load it would be, how much current it will take, how much speed to it rotate, and how many process it can perform within a specific time. So these decides the specific task is okay. And now we set the parameters. What are the parameters? This, how much faster, that means we are deciding the speed, and supporting IO, that means how much input output module we are going to control or we are going to handle, and supporting protocols. So in between the process, can we send the data to the some other modules through some other channels? That is comes under protocol. And shape and the size, how much size is it could be, and internal external memory. So all the parameters decided the actual design of embedded system. So all the parameters are nothing but these are called the parameters. Embedded, which decides the selection of microcontroller and processor. So look at this. Let me show you. Yeah. So this is actual conclusion is MCU for any application we can satisfy the required specification. So these are must be satisfied to design a specific embedded system. Number of IO ports, serial communication modules, the peripheral like timers, ADC, PWM, and memory requirements, and processing speed and power requirements. So these are the basic parameters or basic we can say the specific criteria to choose an MCU microcontroller unit for a specific task of an embedded system. I hope this today's topic gives you a basic introduction of the our today's agenda to developing an embedded system application using MCU, how to design it, what are the issues, and how we can design in a better way to compete the current market scenario. Okay, thank you very much.